So water heaters is going to be our next subject. And let's keep pumping along. All right. A lot of different parts. I think I'm going to take some of these slides too and post them so you could download them and get nice big pictures of them. You should understand how a water heater brings in there, and you're going to be beaten up. Let me just back up a little bit. I hear so many people call these hot water heaters, and plumbers will beat you up, other home inspectors will beat you up. There's no reason to heat hot water. I understand it's a habit, but it is a water heater and not a hot water heater. If you want to say it's a cold water heater, then go ahead. All right, enough of that. I want you to know how they work, though, and how they get the best use of the water that gets heated up. All right. So knowing all the different parts that comes with it, and what we're looking at here is a gas unit, and how we heat up the water, I think is vitally important. So we'll start at the top. All right. We have a red line and a blue line. So hot on the left, cold on the right. The blue line brings the water in. Usually we only need one isolation valve on a water heater, and that's going to be on the cold water pipe. And again, as you're at the front of the water heater, that isolation valve should be on the right pipe, or the right side pipe. Left side is the outgoing, that's the hot water. I actually like it when they put an isolation valve on the hot water as well. If for some reason you need to remove the water heater and replace it, we don't have to drain the entire house to make that happen. So everything is still usable. Just not the hot water would be flowing, but we don't have to drain all the water. So as the cold water comes in, the cold water pipe, we're going to drop down to the dip tube. All right. So you can see the blue water line goes towards the bottom of the tank. So as cold water enters the tank, it's going to enter at the bottom. Naturally, heat rises, so it's always going to be the hottest at the top and the coldest at the bottom. So as long as the hot water is leaving through the top and the cold water is entering at the bottom, we'll be able to use the vast majority of the hot water in that tank. It won't churn, it won't mix, it won't try to equalize out as long as that water is flowing and we're taking a shower. So we'll get the best use out of it that way. Now these dip tubes, that blue pipe that's going down to the bottom, they're fragile, all right? And they do deteriorate, they do break. And if they do break off and it's gone and it's sitting inside the tank, we're not going to see that and we're not going to know it. What's going to happen is that now cold water is going to be introduced into the tank at the top. So that cold water, it's kind of like electricity. It's going to take that path of least resistance and it's just going to flow straight from the right side over to the left side. And we're going to be running out of hot water in a matter of a few minutes. The tank will be filled with hot water. We're just not going to be able to use it because as the hot water is leaving, it's being replaced with cold water at the top. And the wall of water and the rest of the tank just is sitting there. It's not doing anything. So that's what the dip tube is for. Bring it down to the bottom. All right. Going back up to the top. Let's skip over some of the venting. We're going to stick on the left-hand side. All these tanks do have insulation built into them. They're typically about an inch and a half thick of either fiberglass or foam insulation. The newer ones, the Fleurs, they're actually going to have an interior wall where air flows through there as well. All right. The next item going down the list I want to focus on is the sacrificial anode rod. On the left-hand drawing where it's open, that's the rod, the silver rod that goes about halfway down into the tank. All right. Those are going to be made out of magnesium. Some of them are made out of aluminum. I keep forgetting which is which. Some of them are designed for well water, and some of them are designed for city water, where it comes in there. I always have to Google it for some reason, and every time I Google it, I forget it about 5 minutes later. So we can do it again at the end of this, but for now, I'm just going to ignore that. This water that's inside these tanks will eat away at the metal. All right, it's going to cause the water tanks, even if they're glass lined, to deteriorate as time goes on. the purpose of this anode rod is all the chemicals that's in the water, instead of them attacking the actual tank themselves, they're going to be focusing all their attention on the anode rod. And they're going to eat away at this anode rod until eventually it's gone. All right. Now, you can replace these anode rods. The manufacturers recommend that you replace the temperature pressure relief valve and the anode rod every 5 years, and that you flush the system. Don't drain it. You just want to get that water flow out of the drain valve at the bottom. You flush the system once a year until clean water comes out of there, and that way you get rid of all the debris. But yeah, those anode rods get eaten up, the pressure relief valves get eaten up, and to keep them living long and keeping a water heater, and I know one guy who's a water heater fanatic. He's got a 7-year water heater, and I think it's going on 50 years right now. And that's what he does. He just changes out that anode rod and that pressure relief valve. And they do sell hinged anode rods and thicker anode rods so that you can slide it in there and another piece will go in there and you can get the whole thing back in there and tied up on there. I think it's Water Supply Warehouse in Northbrook. And he's a flutist too, and I can't think of his name offhand. Loves to talk about water heaters. I mean, talking about a guy with a passion, he's phenomenal. And you could call him up on the phone tomorrow and chat with him. If he's free, he'll talk to you about water heaters and how he helps Ream and everybody else write their manuals and what's dangerous with them and safe with them and so forth, and how to keep them lasting forever. Not a big fan of the tankless water heaters. He likes these tanked ones. But again, changing those anode rods, changing the pressure relief valves is huge. We work our way down. Let's go over to the gas pipes here. So we do have a gas valve. We do have our gas pipes. We do have a drip leg coming in there. I think those are somewhat self-explanatory. The burner is at the bottom. If we look on the left side of the picture, that's going to create our flame, heat up the bottom of the tank, and then those hot gases are going to go up the center flue. They're going to go up the center flue, they're going to go up the center flue of the pipe until we get to the vent connector. Inside the flue of that water heater is a baffle, and it's nothing but a twisted piece of metal. So as the hot air goes up, it's going to bounce left, bounce right, bounce forward. So it's keep pushing the heat to the different sides of the walls as it's going up. And that just helps heat the water faster. It gives more direct, not necessarily flame content or contact, but heat contact when it goes up there. Once it gets past the top of the water heater, then we want to induce fresh air with it. We want to bring that temperature down. Typically, you're going to be exhausting somewhere around 300 degrees of heat from the top of a water heater. And I'm talking about after, I'm talking about before the draft to it. Afterwards, it'll drop down to under 200 or 200 degrees once I get 70-degree room air mixed in with it. I think that summarizes our water heater. So hot on the left, cold on the right. We want to have a pressure relief valve on it. Pressure relief valves, numbers that you should be aware of. They're designed to open up and stay open, and we'll show that picture in a little bit, at somewhere around 210 degrees. They're also designed to open at 150 psi of pressure. And what's weird is in order for me to get to 150 psi of pressure, I got to get that temperature up to 300 degrees. So not always do the temperature pressure relief valves open, and it may just be a pressure relief valve and not a temperature pressure relief valve. You would only be able to tell that on the data plate. This next one is an electric water heater. We still have anode rods in them. We still have pressure relief valves in them. Excuse me 1 second. My favorite. See if I can move this to a spot where we can read it. If you don't drain it periodically, then there's a chance for hot water to get trapped at the bottom under the debris. Absolutely. You're talking about the gurglers, aren't you? You know, when that pocket escapes, it could trigger too hot of a warning that will shut the water heater off. And one of the, that is a great ad. Thanks, Mark. One of the things to put on that note too, and something that gives you that clue that that's happening, we call those gurglers. All right. So when the water heater is heating up the water and the flame is going, and you start hearing this gurgling sound coming out of the water heater, that's water underneath the debris that's there, and it's turning to a steam. Basically, it's boiling, and that's lifting that debris up and dropping it back down again. That creates that noise. So you got a lot of debris in there at that point in time, and it's either time to flush it or you're going to be looking to replace it. Great ad. Thanks, Mark. With these electric water heaters, we don't necessarily need a dip tube. We don't bring the water in from the top. If you notice, the cold water line is actually just plumbed straight through the outside and comes in through the bottom anyway. So we're not worried about finding that dip tube. And as we go up and out, the hot water comes out of the top. So we're doing the same thing that we were doing before. Bring the cold in at the bottom, hot at the top. We have two heating elements on these things. Don't take the caps off and try to look inside of them. These things are dangerous. There are 220 volts of electric that comes in there. You don't know when they're going to turn on. I can tell you that they do only turn on one at a time. Our next slide. Yeah, so they only turn on one at a time. When the cold water enters and the hot water is pushed out of the top, then it's going to try and recover as quick as possible. So if only we have cold water on the bottom and warm on top, the bottom one's going to go. All right. Once I run out of hot water in the entire water heater, then it's going to recover the top half first. So then only the top element's going to be ignited. Once the top half of the water heater is heated up appropriately, then it's going to turn the bottom one back on so that it'll get the bottom one heated up. And then, of course, when everything's at the right temperature and it's equal, it's going to leave everything at rest. I got to remember to keep putting these questions over on the screen so everybody can see them. Mark was asking me again, why a dip tube on the gas but not on the electric? Yeah, I'm not the expert in designing. I got to make up some assumptions on here. I think a lot of it has to do with the room and the space and the fragility of the dip tube itself. So what we don't want to have happen is for that dip tube to break off and fall up against these electric heaters, all right? If we did that, then we would be creating a direct short in the energized portion of the electric burner or heater and the ground if it falls and leans on it. I think that's why they avoid the dip tube on that. But even with the gas water heaters, I mean, in all reality, it does seem like a smart idea. Just pipe it from the outside, do away with the dip tube altogether, and now you don't have to worry about that dip tube breaking off on the inside. Great question. But that's the only answer I got. Is I don't think they want to take a chance of that dip tube falling off inside and hurting or energizing the tank itself. So this one we kind of saw before. It's a repeat. Next one is going to be an oil burner coming in there. When we talk on heating and we do the heating systems, you are going to be expected to be able to identify if a heating system is an oil burner versus gas versus electric, whatever the different fuels are going to be. So typically with the oil burners, they're going to be, a regular pump like this where it's going to pump in air pressure. It's going to pressurize the oil itself. It's going to create what's the term that they used for that? Atomizing. So it's going to take the oil and it's going to put it through a fine mist spray, and it's called atomizing the oil because it's pretty much just a surface area that's going to ignite. So it needs to have a spray of oil as opposed to a stream of oil coming in there. and that just burns cleaner and nicer when it comes through it. So we have to pressurize the oil, pressurize the air, because I need to have that oxygen mixture in there, all right, when it comes through it. But I still have the same baffles, same dip tubes, same anode rods, same pressure relief valves. Something that is different, though, is I don't have a draft hood at the top of it. So with gas appliances, we're going to allow that mixture of fresh air to be taken in through a draft hood. Because oil burners are not as consistent as gas burners, they need to have something that's going to vary how much air gets mixed in there to cool the temperature off. So in this case, they're going to use what's called a baffle, or a barometric damper at the very top. Kind of looks like the old Napster logo if you think about it. That's actually on a hinge, and that's going to open. So the hotter the air is, the faster the air is going to move. The faster the air moves, the lower the pressure will be inside that pipe. The lower the pressure inside that pipe will cause that valve to open more and let in additional fresh air, slowing the heat speed down until it gets to that happy medium. So we get that flame or that heat speed going through the baffles and the vent and the flue. We get that all through that barometric damper that opens and closes. Water heaters, we do look at the data plates on these things as well. Buildingcenter.org. I know I made mention of this site many a times. I have it memorized and bookmarked on our phone. Whenever you want to try and find out when something was manufactured, then that's the best place to go. Water heaters are typically going to have an ANSI code on them as well. So if we look underneath that star, the American Association, the NRTL design up there, when we look underneath there, we see 1998. All right. So that's the code that this water heater was manufactured under, was the code of 1998. Now, codes typically go for 3 or 4 years in that ballpark. So just by seeing that ANSI code, I know that this thing is going to be anywhere from 1998, 1999, year 2000, or the year 2001. All right. Next thing I do is I look at the serial number. Most of them are going to end up being, the first letter is going to be our month code, and then the next 2 numbers is going to end up being the year of manufacture. So A, B, C, D, E, F, G, H. H is 8. 8 is August. So my guess is this would be manufactured August of the year 2000. And even if I was off, I'm still damn near close. You know, so depending on when it was manufactured on today's date, then, you know, that's where it is in its lifespan. We usually tell people 15 years on a water heater. I know some of them are at 7, some of them are at 30. We like to stick to one number right down the road and figure out where that water heater is in its lifespan.